All right, good morning. Here we go again. I'll try to get through this. Number 8, 9, and 10. I think you guys can do that yourself. We've talked about a lot of those things in class already. Number 11, we're talking about young Brian Miller going around the track 2 times. It's a 400-meter track, and he's going around it 2 times, which means he'll have traveled 800 meters. He does that in 21 minutes. So you could go ahead and just divide those, and you could get a velocity of 38 meters per minute. And if you convert that to meters per second, so you should practice doing that. You should get 0.63 meters per second. And that's his average speed, which is the total distance traveled divided by time. Instead, if you do his average velocity, you're going to take the displacement divided by the time. And the displacement here is 0 because he goes around this circular track, so Brian ends up where he started. And so his displacement is 0, and so 0 divided by time will give him an average velocity of 0. The other way to think of it is that the velocity is a vector, so sometimes he's going to be running north, but other times he's going to be running south, and those are going to cancel. And since he gets back to where he started, all those velocities cancel out, and he ends up with an average velocity of 0. For number 12, looks like we have 3 graphs. This one needs to be the acceleration, okay, which makes then we have a change in velocity here that's nice and consistent, which is how we know that this is a velocity curve. And whenever you have a change in velocity like this, where it's diagonal in the velocity curve, that means that the position curve needs to be a curve, and that comes from the acceleration being constant. It means we're going to have a parabola here. You can think of it in the equations where you have d equals 1/2 t squared. So that's how we know this one's a parabola. This one's going to be linear, y equals mx plus b. And then here we have a constant on the acceleration. Here we have another nice easy question. Let's take a look at this. Again, this is just with constant velocity, so that's nice. We're talking about David being able to run 8 meters per second, and if he's going to go 1.2 kilometers, we can recognize that he will solve for time here. So we get distance, which is 1200, divided by the velocity with 8 meters per second. So we get 150 seconds, which is 2.5 minutes. Instead, if it asks if he can maintain the speed for 1 hour, which would be fairly impossible, 8 meters per second is very fast. How far will he have to run? And that ends up being 28 kilometers in 1 hour, which is amazingly fast. But in any case, we would take the 8 meters per second times the time, which is 3,600 seconds. Notice we have to get to seconds. So from 1 hour, we're going to go 60 times 60. And that gets us to the 28 kilometers, which would be a great run. Okay, for 14, I think I'm going to start over and get another video going. Thanks.